Welcome. This week, specifically, we're going to be looking at vector data and how to manage vector data. And as you already know, there are two main data models that we use throughout a GIS. One of that obviously is going to be vector. The other one that we've talked about is raster. And so hopefully you'll remember too that vector data is looking at the specific XY coordinates that make points, lines, and polygons, while raster data is looking more at those pixels. So when we're taking an actual photograph, an image, and implanting that into the GIS. So specifically when we're looking at our vector data models, we know that we are dealing with the data that is stored as XY pairs. Again, they come in points, lines, and polygons. And crucially is that each XY pair is going to be called a vertex. If we have multiple vertices, what they are called a vertices. And so you can have multiple vertices making up a line, and we always refer to the endpoints of any line as a node. But a multi-part feature, that is going to be something that is going to create a polygon where we are going to have a bunch of vertices, and collectively they can come together and form multiple or separate pieces and can all be linked into a single multi-part feature. Each individual feature makes a feature class, so whether it's a feature class of points or lines or polygons, they can be stored together, something that you've already seen. We can link these features to specific tables. In this case, they'll be our attribute tables, where this data and attributes and features of this data is going to be stored. And in order to link the spatial data with the attributes, we have to use a special field, and that is called the feature ID or the object ID, where each feature's attributes are stored in one row or a table, as you can see here again with the attribute table. And this creates a link between the spatial and the attribute data so that it can be displayed and create a map. As I just mentioned, a feature class is in essence a collection of similar features that are stored together in a data set. In this example, it is going to be states. And importantly, a single feature class will only contain one type of geometry, aka points, lines, or polygons. And feature classes will be stored in a variety of formats. We've already seen and worked with shapefiles. We know that they all get stored in geodatabases and so on. And we will definitely talk about this in greater detail as we continue. But first, let's talk about the two types of vector models that exist. The first of which is going to be what we call the spaghetti model. A spaghetti model stores features as independent objects that are unrelated to each other. In essence, two adjacent states, for example, may share the same boundary, but a spaghetti model stores them in separate polygons. This saves the shared boundary twice without recognizing the relationship between the two states. And the reason that a spaghetti model can be important is because each state has its defined boundaries. It means that you can take the data from a single state and you'll have its entire shape or its entire feature class that will be able to go with it. So that if you were to take, let's say, the state of Oregon and want to drop that into another map, you would have its full border rather than only a partial border if the state of Oregon's border were relying on these other features. So in that sense, it is a relatively simple model, but it's great as it allows us to transfer data from one GIS into another. And a topographical model not only stores features, but it also contains information about how the features are spatially related to each other. So whether there is a common boundary, or whether two lines are attached to each other, or perhaps they cover a same area. This allows us to figure out whether states are adjacent, or I should say lines, polygons, or points are adjacent, if they're connected, if they overlap, if they intersect. And this is the type of information we need in order to run certain geoprocessing so that we can understand the relationship that they have with one another. And at times, this is also very beneficial as it can help us to find areas to see if there are things overlapping, meaning that perhaps the data is incorrect. especially if we are looking for specific state boundaries in this example. And so as you've already seen, you know that GIS data can be incredibly large data. It is incredibly complex. There is a lot to it. And that's why in general, it's really good to get a better understanding of the characteristics that are involved with GIS data. Thankfully for this intro class, you're not really going to be dealing with too much of this other than we know that the files can be really large. And as I say during our lab practices as well, make sure that you save your map as often as you can so that you don't lose any of the work that you've done. But also more importantly, if you can tell that the program is thinking, let it think so that it doesn't crash. For the most part, if you were to do this professionally, often you'd have to share the data with multiple users, or data may come from multiple sources, which might change the file type that you'd be dealing with. And as you've already learned, you might have to convert some of those projections to make sure that the data displays accurately so that you can analyze it effectively. And again, dealing with file conventions and how to store file and where to save that data. All of this could be an issue later down the road, but for now, we just really have to worry about files being large, as the rest of this you won't have to do, or you won't have to deal with, as all of our data has been supplied for us. What you will have to deal with, though, is becoming really good at or continuing to learn how to best manage and file and store your GIS data. So, I mention this all the time, file management, well-organized folders is going to be key. Learning how to navigate through or continuing to improve how you navigate through your file tree, making sure that you're constantly storing the data in each new layer that you might be making back to that geodatabase that is stored back in the GIS data folder that is back on your USB. You always want to make sure that your data is going back to where you know you're going to be able to find it. Whenever you're downloading data, you always want to make sure that you are putting it exactly where it needs to be and not saving it in a random location, because that's how data gets lost. And as we've already run to a little bit during class time, when you get that red exclamation mark, it's telling us that the contents pane is no longer linked to the data, so you have to go back and make that connection again. So thankfully, when you are managing your GIS data and you're managing your file storage, you'll know exactly where to find that. So tips to managing your GIS data is crucial and is going to remain crucial to really mastering the introduction of GIS. Regarding other best practices, I want to go over this just super quick. There are definitely some better and worse ways to try and store your data. You never want to have any spaces. This is a general key when dealing with any sort of GIS data. All of these quick tips are going to be incredibly important in order to best store your data. So I would take a minute, pause the video, read through this, just so that I don't have to tell you exactly what it is. Again, dealing with file extensions, making sure that you are using the correct code, making sure that you are changing the computer settings to make all of the extensions visible so that you know and can locate that file that you're looking for is going to be crucial. And I know that we've already discovered this, especially when it comes to dealing with really large data sets and downloading and importing large data sets. When we come across files that are locked, or more importantly, if a file is zipped, we have to first unzip that file so that we can actually access the data that is within those files. This is obviously something we had to do on our first day to download the data that we used during the class time. But again, so making sure that your computer system is able to open those files, which of course they will, but also knowing if a file gets corrupted. So if you continue to have issues with accessing your data, none of the data is going to be changed. If you are afraid that you have corrupted your data by moving it from one USB to a desktop to another USB, back to another desktop, when you're just copying and pasting files, there's always the chance that something can go wrong. So if your data at some point seems to just have issues, Before we create too many more files, I definitely recommend trying to just download it again. You're going to get that zipped file and you're going to have to unzip that file and download it as well. This goes right along with importing and exporting our data files. Super important stuff. I know it can be relatively boring and tedious, and we haven't quite gotten to having to export our own data, but when it comes to that, there are always going to be clear directions to follow, and it is essential that you make sure that you are doing or figuring out functionally what the purpose of your export is, making sure that you are saving that file in a file-friendly manner, and making sure that you're always storing your data in the location that you want it to be. You want to make sure that you're always putting that data where it needs to be. Beyond this course, you may often also be tasked with compiling your own data, and that would again mean assembling various GIS data from different sources. Depending on how large that data is, right, the scale of the data that you are working with, it can often be incredibly effective or advantageous to actually pare that down. So let's say, again, you want to make sure that you are paying attention to the source scales, making sure that you are not only working with data that has been collected and being displayed at the same size, but also, for example, if you are getting data for, again, the state of Oregon, but it's coming from a national data set, you may want to import and export certain files, feature data sets or feature classes, so that you can pare that down and only work with the data that you need for your project. Because again, small scale data is often easier to work with, easier to find, and again, if you're using data that is too large for your project or any project you have in the future, that just may slow the entire process down. And obviously, when it comes to using data that you display in a GIS, all of the data that you use doesn't necessarily have to be found somewhere online or be given to you by someone else. You can actually create your own data. And so generally when we are creating our data, obviously when we're using vector data, you are going to be focusing around mapping XY coordinates, and generally you will be importing these coordinates from a data table. Generally when we are working with this, you will be using XY coordinates, and you will be doing that using an Excel sheet where you can collect all of your XY values that must be given in a real world coordinate system, such as latitude and longitude or UTM meters. If this sounds familiar, that's because we talked about this last week, the different geographic coordinate systems that are involved with displaying our XY coordinate data or our latitude and longitudinal values on a map. And so you have the opportunity to input XY coordinates from a data table, even if it's a data table that you have collected. You can plug that into the GIS. You're going to need to set the parameters. Again, there are specific tools and features so that you can, for example, take an XY table, one that you've created, and create or, take an XY table to points. So you're going to create those digital points. And again, you just have to make sure that the coordinate system of the locations are going to match up with the coordinate system that you're using already on the map. And this must be specified in the XY tool. So all of this is going to be able to be done when you're importing your data. Again, specifying your coordinate system, your geographic coordinate system. An event layer is a unique situation. A table with coordinates can have the locations displayed on a map as an event layer, meaning that it is going to be automatically generated or saved as a point feature class. So an event layer is, in essence, the result of a geometry, aka XY data, being dynamically generated from a table. Again, we call that a tabular source. And so while an event layer is dynamically generated, a feature layer points to data whose geometry is already defined in the feature class. Interestingly, an event layer is the result of geometry, aka those XY coordinates, being dynamically generated from a tabular source, aka a table. While a feature layer while a feature layer, points to data whose geometry is already defined in a feature class. Again, those are those XY points. And so that's basically the difference. One is dynamically generated, the event layer, and the other one is predefined. And because this is being generated dynamically, it is not yet stored in a geodatabase, and thus it is considered an event layer. But you could always export this event layer and store it in a geodatabase, which would ultimately result it in becoming a feature layer. So I know that's a little confusing. Thankfully, you're not going to have to deal with that too intensely. But again, this terminology comes from considering each entry in a table to being an event. Again, this is straight out of the textbook, such as an earthquake or a traffic incident, further highlighting how it is representing an event that is happening, and that is why it's being displayed dynamically and creates a temporary spatial layer. So I don't really want to jump into too much detail about the next few items that are listed throughout the book, because again, the definition that the book provides for geocoding, as well as how to extract data, merge data, the rules required for merging data, and again, all of these various data processes that involve modifying and managing data. The definitions that you can get out of the book are pretty straightforward, and these are not things that we are going to be doing just yet. So I definitely want you to take a look through them, read over them. Again, there may be a quiz question you'll have to answer about some of these processes. But what I really want to focus on is looking at the different types of data. So while I know that we have already talked about metadata, again, generally we refer to that as data about data. It helps, again, the user to assess the purpose of the quality of the map, or really what we're looking at. So this metadata is crucial, and every data layer file that you're looking at should come with metadata. But what's going to be new for us is really taking a look at the different types of data that get used in an ArcGIS. And so many of this may sound relatively familiar. I know that I have talked about some of this before, but this is going to be the first time that we are really diving into the different types of data. So if I can focus your attention to any specific part in the chapter, it is going to be the data forms used in ArcGIS. And again, that is starting on page 153. So that should be where the majority of your time and effort should be going for this chapter. So please familiarize yourself with these terms as I will go into a little bit more detail. A geodatabase, this is one that you've definitely heard me talk about. Most importantly, it is the native and recommended format for ArcGIS Pro. A geodatabase can contain many different types of information, different data objects, different feature classes, networks, tables, rasters, all of this different geographic information that we are using currently on our projects that will be displayed in your map. All of that data can be stored in a geodatabase. Again, I know that you are familiar with the Oregon geodatabase because we have taken these different layers, these different files and tables, and imported that into our maps so far. So really, the geodatabase is the main container, if you will, the folder that will store all of this different information in one central location. Again, if you're following along with your book, there is a great image on page 154, table 5.1, the vector model data sources used by ArcGIS. This is a great table showing you the different uses or functions of the different file types, as well as providing a description for how they are, again, best utilized. Additionally, there are different types of geodatabases, and while this is important if you pursue GIS beyond the introduction class. This is not something that you really need to become familiar with. The biggest difference here is that a personal geodatabase is not recognized by ArcGIS Pro, so you will not really be working with this. If you are working with ArcGIS Pro, which again is the industry standard, so you don't really have to worry about that. And unless you are working for a major company that has to deal with security issues or networking, supporting multiple users, you also will not be working with an enterprise geodatabase. What I want you to take away most is knowing that there are 3 different types of geodatabases, but further than that, you don't need to know anything more deeply than the fact that there are 3 types of geodatabases for the purpose of this course. What is more pertinent is understanding the shapefile and the shapefile format. So a shapefile is a spaghetti data format containing a feature class composed of points, lines, or polygons, aka they make shapes. Shapefiles have a common format that is recognized by both geographic information systems and GPS global positioning systems. And they are often used to share information between different GIS and remote sensing programs. Although shapefiles appear as one icon in ArcGIS, and that I know that you've seen that because you have dragged a shapefile from your catalog into your contents pane, and again that's going to be any of the files that end with a .shp. But each individual shapefile is actually composed of multiple data files, which you can see in this image here. So all of these different files are basically combined in order to create one shapefile, and each file type is going to be responsible for a specific set of data that will display on your map. And it's really important to note that you don't ever really want to mess with these, because if you change the name of one or you remove one, you're going to mess up the rest of the shapefile. So that's why generally it is very important that you don't ever want to go deeper than this layer when you're poking around in your data. You never really want to pull these apart. So when you're copying them or renaming these shapefiles and moving them in and out of ArcGIS, it is super crucial that none of these ever disappear. And again, you'll only get to these if you double click on one of these shapefiles. Because again, all of these comprise the shapefile. And as I alluded to previously as well, dealing with the geodatabases, a coverage format, again, is an old vector format that is no longer recognized by ArcGIS Pro. So I doubt that this is going to be something that you'll be coming in contact with anytime soon. But again, that doesn't mean that it is not important to know that there is older GIS formats, or where GIS data has been stored, that can be converted or must be converted into a shapefile or a geodatabase so that it can be used for and seen and recognized by ArcGIS Pro. Again, something that you're not going to be dealing with, but knowing that obviously there's older data out there and older data storage formats and files is going to be important if this eventually does become an actual career option for you. So there are other types of data. Again, we will not be using them, but knowing that they exist is important. I would say that the best chances of coming into contact with any of these might be a CAD file. A CAD file is a computer-aided design file, and unless you wanted to take GIS and work for a city, maybe for a planning department, or maybe even for an architecture firm, I doubt you'll be working with CAD files in your GIS career. And so this also shouldn't be new knowledge, but GIS data generally gets shared between multiple users. And for this reason, it is crucial that the data that gets used by these multiple users is always accessed in the same way or shared in the same way, and generally that certain procedures get put into place to prevent simultaneous editing. But to break this down so that it makes most sense for us, this is also incredibly crucial, again, because this just kind of comes back to making sure that you know what you're doing and you're actively choosing to save a file in a specific location and you're doing it with purpose. This brings us to path names and making sure that you can locate the source of the data and knowing that, and you'll be able to do this because you're absolutely sure where those paths go, where your data is saved. I know that you've already become familiar with this data path or this data tree so that you can see the specific path that it is taken to get to that GIS layer that is stored in the Creator Links database, right? This bin of data, or perhaps in this other folder. Hopefully these look familiar, the class project folder or the MGIS data folder. These are the different folders and geodatabases that you have been accessing for your for your maps currently. And so again, following this file path, and I've tried to indicate this in some of my labs as well to make sure that you are actively going to the place where your data is stored. Again, I point out as well, they start with the C drive. You will always be starting with your USB instead of the C drive. But again, going up or down this folder tree, that's why it is called a tree, in order to make sure that you're going down the correct path is very important. And why is this important? Because if you ever needed to share your data or wanted to save your own data and make sure that you do not forget where you saved a specific file, feature layer, shape file, or a geodatabase, you can literally copy that entire project folder because without that folder or the geodatabase, your map file, which is the APRX file, will not show. And so again, if you were to just copy the map file, you wouldn't have the geodatabase pointing to it. And same thing, if you only copy a geodatabase, but your map consists of data coming from multiple geodatabases, right, which is something that it can be happening right here, then you will not have it all display. So making sure that your map file and your geodatabases and all of the other shape files are stored within the same project folder, and that's something that y'all are doing right now, is going to be incredibly important. And so same thing, we've talked about how when that red exclamation point appears by the map layer, you have to re-establish that link. You have to recreate that link. So because you know that you have your path name, you will always be able to connect this layer back to where that shapefile or feature class exists in a specific geodatabase. And typically when you create one connection, all of the other ones are going to relocate because the ArcGIS helps us to connect those paths. And for this reason, we mentioned it earlier, you never ever want to put a space in the folder name because this can actually destroy that link. So you never want to leave a space, use an underscore, use a hyphen. Often too, you can't use special characters, but it should let you know that if you try to save something with a special character. Also, you don't want to rename a project because that can also disrupt a path name. So if you were to, again, jumping back up to this path name, but let's say you changed this Oregon folder, which is going to be this Oregon folder, and you changed it to Oregon 1, then any other path name that would previously exist that would be using this path name would get broken. So that's why too, when we talk about file management, when we talk about data management, this is why it is so crucial when we are working with our different and variable GIS data. So I just want to highlight again how crucial it is to preserving your path names, understanding how these data trees and path files and path names work, knowing that we have different data types, knowing what constitutes a shape file, and that we have different geodatabases that can store all of these different file types or data types. All of this is crucial to literally unpacking the data that can be stored in a GIS. So again, the rest of this is more or less compiling data or looking back at what we've talked about previously, understanding the importance of the coordinate systems. It'll remind you of specific coordinate systems. And again, thankfully, this is not something that we're going to have to deal with. And if we do, there will be instructions for how to reset that coordinate system. So this won't be something you'll ever have to do on the fly. But again, knowing that the coordinate system is important because you need to pick suitable coordinates in order to display or project all of your geographic data. All right, so I know again that was a lot. I cannot emphasize enough that listening to this PowerPoint is supposed to help guide you through the chapter. Reading the chapter is definitely important. And again, using the images, or I should say the tables and the figures that exist throughout the chapter, I think is also probably the best way to get a better idea of exactly what we're looking at until you get your hands on it, or I should say digitally, while working in AGIS. So hopefully a lot of this already seems somewhat familiar. I know that you've become much more confident in navigating through your different files, accessing your different geodatabases, as well as working within the maps. I know that you can import and export data, and definitely something that we're getting better with at every lab that we do. So keep up the great work. Hopefully this helps. Otherwise, if there are any questions, please feel free to reach out to me. I am always available through Canvas inbox. Thanks.